Hello, everyone. Thank you for joining today's webinar. Excited to be here. We are excited to talk a little bit more about Evoqua's solutions. Before we begin, I'll give you a brief overview on Evoqua. Evoqua is a leading provider of mission-critical water and wastewater solutions. With a global team of over 4,000 across 150 locations, we deliver world-class products and services for various different verticals, from healthcare to pharmaceutical, to data centers, to universities, to even district central utility plants. Today's webinar will focus on how Evoqua's next generation filtration technologies can really help maximize your cooling system uptime. Hello, everybody. My name is Mike Ditton, Global Product Manager for Evoqua's Advanced Filtration and Separations Division. I'm here with my colleague, Gary Hagler. Gary will be starting today's presentation off, and he'll be giving you an overview of various different cooling systems, pain points, problems, and ultimately today's mitigation solutions. I'll be taking it over a little bit later to talk about some of the solutions. Gary, I'll turn it over to you.
All right, thanks, Mike, and good morning. Thank you for joining, and it's our pleasure to have you on this webinar. We hope that you'll find it to be a good use of time. Now, I want you to feel comfortable with me as a subject matter expert, and so I'm going to share some things with you that I believe will bring a lot of credibility. So think of it as a little expanded intro. So first and foremost, I have 5 kids, therefore I have 0 friends. So I got a lot of mouths to feed, a lot of bills to pay. I need a job, so I know this stuff. I'm going to be able to hopefully help you with that sort of thing. Secondly, I'm allergic to poultry. So if I eat any chicken or turkey, I go into anaphylactic shock. People always ask me, Gary, what do you do for Thanksgiving when you can't have turkey? Well, being a boy from Michigan, I always woke up and watched my Detroit Lions lose, and then I finished the day off with a frozen pizza. So that has nothing to do with filtration, but just thought you'd like to know a little fun fact. Also, I'm a pretty big deal on the retail scene. I don't want to brag, but I do have an executive level membership at Costco. And finally, and I would say most importantly, I say this with all humility, you are in the presence of greatness. Now, why would I make such a bold claim? Well, your presenter is a 3-time state champion in the sport of roller skating in the state of Michigan. People always ask me, why did you do this sport? I always tell them I did it for the ladies, although that never really panned out, probably because I wore a hot pink unitard and my hairstyle of choice was a combination bouffant mullet. So you can imagine growing up, I faced a lot of pain and ridicule as people learned about my sport of roller skating. And now that I've earned your trust and built some credibility, it's time to talk about your pain. It's your turn. So when we talk about cooling water systems, there are a lot of pain points, but we just want to talk about 4 really quickly. Number 1, increased maintenance cost. So whether you have to replace the fill or the cooling tower basin or the piping, or you have excess energy costs, maybe the biofouling or scaling, this is a big deal. I'm sure you've all experienced it. Then there's the red tape of more stringent environmental regulations. You go clockwise from there, you see downtime. I don't have to explain that to you. You're all familiar with that. We see the guy here in the picture punching the tubes of a chiller, having some issues there. And then lastly, waterborne pathogens like Legionella. So those are some of the pain points you may have experienced. Not a comprehensive list, but I'm sure all of you have experienced some of these at some point. So why does this happen? Well, a cooling tower, first of all, I would say it's a big air scrubber. It's going to suck in anything around it. So whether that's construction materials, leaves from a tree, any types of particles, nutrients, heck, Snickers wrappers. We've all seen some weird stuff in cooling towers before. It's going to bring all that into the system, and that has to be dealt with. Also, the cooling tower is a dynamic system. So you have makeup water in, blow down going out. You may have multiple chillers or multiple heat exchangers, and maybe they're not always all operating. So you may have some areas of stagnant water or low flow, in which case bacteria can grow, corrosion can happen. You may have an intricate piping system and there's dead legs in there, again, where corrosion and biofilms can form and start to cause some really troublesome fouling issues. So it's a very, very dynamic system, and that's where fouling can come from. Outside of the normal just corrosion products that would be in your system from metal and water being put together. So the biggest issue, though, with a cooling system, I believe, is the fact that bacteria can really cause some headaches. And so I'm sure you all are very familiar with Legionella and other waterborne pathogens, but this can cause some major issues. And then just having to have a program with that, whether it's a water safety program, a Legionella testing, remediations, all the bookkeeping, all that can be very cumbersome. But why is bacteria such a big deal for cooling towers? Well, it's got the perfect environment. Cooling towers have warmer water. Typically, the water temperature is in the sweet spot for bacteria to grow. As we mentioned before, it's a big air scrubber, so it's sucking in all those nutrients. It's got a lot of nutrients to feed it. Lastly, it's also sucking in silt, sand, and debris. And that creates a nice protective habitat where those biocides can't get in and penetrate that, allowing that biofilm to grow and proliferate. So it's got that perfect environment for bacteria growth, including the bad L word, Legionella. So you can see there's a lot of pain points, a lot of things that can cause you some headaches, but now I would like to do a poll and figure out where exactly specifically your pain points are. So we are going to go ahead and, Paul, we're going to launch this first poll. So this is we just want to know, and you can only pick one, but what is the most problematic area for you? Is it the environmental regulations that causes you the most pain? Is it the waterborne pathogens like Legionella? Is it increased chiller maintenance, or is it downtime? So I'll give you a few seconds to go ahead and click on the one that keeps you up at night. All right, just a few more seconds here. Give you a minute to get it loaded up. All right, so it looks like it was a pretty decent split across the board, but taking home the winner was the increased chiller maintenance, which is not surprising. The other ones were very, very similar, but that seemed to be the one with 56% that was on most of your minds. And when you think about that increased maintenance to your system, let's talk about now what do you typically do to mitigate that or to help that? What's been kind of the status quo to helping you increase, I should say, decrease your chiller maintenance? And so if you look at what is typically done, advance the slide here. There we go. Okay, if you look at what's typically done, what you see on the right-hand side is the cooling water triangle. So this is what you're trying to prevent from happening in your systems. You're trying to prevent scale, you're trying to prevent corrosion, you're trying to prevent fouling, and smack dab in the middle of that triangle is microbiome. Why? Because if your bacteria is out of control or you're having issues with it, it can result in scale, fouling, and corrosion. So bacteria is really the key, because if you get that under control, keeping your scale, corrosion, and fouling in check is much, much easier. So microbiome is the key. And so how do we reduce those biofilms? We reduce them through removing the nutrients that they can eat to grow and removing the suspended solids that they have. They like surface area to start to grow on. And so those are the things that we want to do. And so you guys that said in your poll, hey, increased downtime or increased maintenance, excuse me, is the problem that we have. Well, this is what's typically done. There are 3 things that are typically done to help you improve that situation. First is prevention. Most of you probably have use of scale and corrosion inhibitors, oxidizing biocides, maybe non-oxidizing biocides if you're one of those people that like to follow best practices. So there's prevention of those things from happening and growing, like microbiome. Secondly, there's reduction. Maybe there's some great engineering work that's been done to kind of engineer the systems to remove or reduce low flow zones and dead legs and those sorts of things. Maybe that does include some side stream filtration. And then lastly, there's mitigation. Maybe you have your annual or semi-annual cooling tower cleaning and disinfections. Maybe you're doing it due to remediation. You've had perhaps a problem or high Legionella levels, but that's what's typically been done to kind of help you reduce the amount of chiller maintenance that you have to do. So prevention, reduction, and mitigation. So if we look at these systems, and there's our cooling water triangle again, we talked earlier about one of the things a lot of you most likely do is you use scale and corrosion inhibitors, as well as oxidizing and hopefully non-oxidizing biocides. Well, I would argue that filtration is the missing puzzle piece to helping you have a system that allows you to not have scale, corrosion, bacteria, and fouling. And so you're putting those chemicals in there and they're doing their job, but they can't do their job if you got a lot of debris in there. And so Mike is going to talk about this a little bit later in more detail, but just on a high level, if you think about all the sand and silt that may be in a tower basin, for example, when you're adding those scale and corrosion inhibitors, the corrosion inhibitor can't lay that nice protective film on the metal to prevent the corrosion cell. You add in those biocides, oxidizing, non-oxidizing. Again, it cannot penetrate all that sand, silt, and debris. And so the bacteria has a great, nice habitat to grow with nutrients and proliferate. Filtration is absolutely the missing puzzle piece, in my opinion, for you running a really, really good program. But I don't know what kind of program you run, and we'd love to hear what kind of program you run. So we have another poll here as well. And that poll is to see how you are currently managing your program. So again, you can just select one choice here, but we want to know, how are you currently managing your program? Are you just using chemicals, scale and corrosion inhibitors and biocides? Maybe you're using a chemical-free treatment like a Dolphin or a Pulse Pure, or maybe you're using a combination of the chemicals and filtration. Maybe you are a best practice follower and you got filtration as well. And lastly, some of you, we'll be very honest if you answer this, but maybe you're not managing it at all. So I'll give you a few seconds here as well to click on the one that you're currently doing. Just a few more seconds. All right, here is the breakdown. Looks like there are two clear winners, mostly chemicals you are using, and then a good number of you are using chemicals with filtration as well, which is fantastic. Some of you, a small percentage, are using the chemical-free treatment programs, and then another percentage of you, 12% of you, are very good truth tellers. You're not managing it at all, so thanks for being honest there. So with that being said, it looks like a good number of you are not using filtration. And again, talking about that as the missing puzzle piece. And now we've reviewed not only the pain and kind of the status quo way of taking care of things. Let's dive into the next generation technologies and solutions that Evoqua can provide. So to do that, we are going to talk about the three technologies that are shown on the right side of the screen. And more specifically, we're going to talk about these three technologies. First of all is hydrocyclones. Second of all is what we call our VAF automatic self-cleaning screen filter. And lastly, we're going to talk about the Vortisand microsand filter. And we're going to talk about these in order from larger particles to smaller particles. And that's the graph that you kind of see there on the left. It's showing you what size particles these are typically good for getting out of your system. So hydrocyclone separators, they're good at roughly 100 microns and upward. The VAF screen filter, that's great for about 10 microns and upward. And then the Vortisand microsand filter filters all the way down to a half a micron, which is really, really small. So those are the three technologies that Mike will be talking about in more detail here in a minute. But I just want to share with you just some ideas of what this would look like. So here is a very simple schematic of a cooling tower system with a chill loop. So you got your chill loop, you got your condenser loop. And where are all the places where you might be able to use these technologies? Well, it depends. Once you understand the area that may be causing you issues, you're going to be able to attack that area with some new tools in your arsenal that we're going to go through here in a minute. But here are just some typical spots you might see that maybe you need to put something on the makeup water. I've had folks before pull from a river that's very dirty. And so that makeup water is very dirty and they want to get that cleaned up before they introduce that into the tower. Bullet point or point number 3 there, the basin. If you looked in your basin before and you got a lot of sediment built up, maybe that's a great spot to do some filtration, some basin agitation. Number 4, the side stream filter there. That's a great place to put a side stream filter because you're going to get that water cleaned up before you send it back to your heat exchanger and your cooling tower. And then lastly, number 5, don't forget about closed loops. Although they're closed loops, we often know that there could be leaks. So there's a lot of makeup water, especially if you have a makeup meter, you can see how much it's losing per day. There can be construction projects. And although that is a closed loop, a lot of those have high oxygen contents. And so really can increase the corrosion rates of the mild steel. And so again, depending on your specific situation, these products that Mike is going to run through can really help you in a variety of ways in both your open and closed loop. So with that being said, now I'll turn it over to Mike Ditton, our product manager, to share with you the next generation solutions that we're able to provide in more detail. Mike?
Thanks, Gary. Thanks for the intro. Good morning, afternoon, everyone. I appreciate the introduction. A note on closed loops. Remember, closed loops can be quite significantly large, and depending upon the operation of your system, you could have significant amount of dead legs of various different loads. So starting those loads up at various different frequencies can cause a lot of disturbance in that closed loop, kicking up quite a bit of dirt and debris and fine particulate in that closed loop. So yes, to Gary's point, don't forget about closed chilled loops. All right, so we're taking things off into some of the product solutions. Let's start with the hydrocyclone separator. Gary mentioned earlier, hydrocyclone separators are definitely a portion of the mitigation techniques of filtration. But remember, hydrocyclone separators are not filters. They are ultimately separators. But this technology is really the workhorse of the cooling industry, providing a robust solids protection for various different customers. But let's look deeper in what this technology can really do. When you look at centrifugal separators on a capability of micron performance and compare that to various different particulates you might find in a cooling environment, it's actually very interesting to see what the technology can do. Centrifugal separators or hydrocyclone separators, really, 100 micron nominal, I would say, depending upon the specific gravity and the type particle, but it's a good average micron removal. When you compare that to various different particulates in a cooling system, you can find beach sand as an example, or even human hair. So it's really important to understand what the technology's capabilities are when you're choosing that type of technology for your solution. Now let's look about how, again, this technology works. As I mentioned earlier, hydrocyclone separators are not filtration, but they are very good at separating very dense, heavy particles. The technology works by really injecting a high velocity flow tangentially into a vessel, creating a centrifugal force. That centrifugal force acts as a pull and separation of high dense particles. So the greater the variation between water's gravity and your particulate's gravity, specific gravity, the better efficiency of separation you'll have in that cooling environment. So this technology is really good for particles that are greater than a specific gravity of 2.6 or higher. And anything that is less than that, you ultimately have varying different efficacies. So this technology is really not the best when you're dealing with cooling systems that ultimately have high levels of organics, or even very fine particle sizes, colloids, or even fine silts. Those types of particles are ultimately not really able to be removed at a very high efficiency. Overall, this technology is capable of removing about 98% of the load greater than at a specific gravity of 2.6 or higher. But this technology's capability is not just depending upon specific gravity and the particle, it's also a function of velocity of the water flow. So it's very important when you're selecting this technology, not just to make sure it's the right acceptable technology that'll remove the particle, but also you're sizing it appropriately, that you are sizing the pump and its flow to maximize the flow rate associated or designed for that specific model. So make sure you have very high attention to the proper flow rate you're utilizing. Now, hydrocyclone separators are really the robust workhorse, as I mentioned earlier, for providing solids protection, automatic solids protection within a cooling system. Improve water quality. Right? We're really removing sand, very large, heavy debris from a cooling system that really allows operators to avoid the associated manual labor, shoveling out tower basins, exposing your staff to various different health hazards, and even potentially the high cost of solid waste disposal. That can add up quite quickly over the course of your operational season. This product is an automatic operated technology. We provide an automatic purge valve controller that really allows the flush capability or the discharge of the solids down to your waste environment. No manual operators are required to go out and interact with the with a product or provide any type of manual cleanings. And this technology is really built for optimizing runtime, long lasting, heavy duty carbon steel, really no moving parts. So the separator itself has no moving parts within it. And this is really built for minimal downtime and very minimal maintenance. Let's look about a little bit deeper inside the overall offering. This technology obviously comes in both a skidded and non-skidded skid scenarios. We even have various different recovery vessels, reducing your solids loading discharge. But again, this technology recently, Evoqua made an investment into optimizing the design to really bring down costs, bring down footprint, improve upon the sustainability of the overall offering. We've chosen tamper-safe resistant starters, really focusing on safety, efficient layout of our piping, simplicity of the automatic purge valve, but really a lot of optimization was focused on reducing footprint, 15% reduction in footprint, but also weight. We want to make sure this product allows to be fit and utilized in various tight utility rooms or continually shrinking amount of available space in your cooling tower environment. All right, so now let's take another poll question. So I'm interested to hear from you on, if you're using hydrocyclone separator. So it sounds like a number of you are using a combination of filtration and chemical, so great. But I wanted to understand a little bit more about, if you're using hydrocyclone separators, are you still observing various different types of fouling throughout your cooling tower that is ultimately continuing to cause some difficulty of maintaining and operating? So I'll give a couple moments here, basically answering, are you using it, yes or no? And if you're not using a separator as well. So I'll give you a few seconds here. Again, probably this is the most common technology utilized in a cooling environment. Interested to see how you are experiencing the efficacy of this product. All right, so looks like the poll is in. Sounds like we have a majority here. A few of you are using separators and still observing fouling. Not many of you are seeing any fouling, but looks like quite a bit of you are not using a hydrocyclone separator. Very interesting. So excited to hear that you're using potentially other technologies. A great segue into the next section. All right, so for the next section, we're going to be talking about the VAF filtration systems. The VAF is an automatic self-cleaning screen filter, a patented technology that provides very robust filtration at various different filtration levels. This technology has the ability to change in and out various different screen sizes. From 10 micron all the way up to 1,000 micron with various different mesh sizes in between. So depending upon your needs, this technology is very versatile in its capability. Again, this product works on its own internal water pressure. So filtration is very basic. It's very simple operation, but this technology is really differentiated by how it cleans itself. And it cleans itself by utilizing its own internal water pressure. No additional accessories, no electric motors, no pistons, no hydraulic systems are really required to operate the cleaning system. Again, it's fully automated, that works on a DP controller that ultimately cleans itself throughout its operation. And the product comes in various different sizes and models and configurations, from 200 GPM all the way up to about 3,500 GPM, depending upon your solution. And it comes both in a skidded operation as well as non. So now, again, I mentioned it has great capability of very different micron degrees. So I talked about centrifugal separators before, going to around 100 micron. Screen filters now, capability of going all the way down to 10 micron. So now we have the capability of removing a lot more particulate in a cooling environment, right? Remember Gary mentioned earlier that cooling towers are really air scrubbers, bringing in a lot of different types of particulate and debris from the environment. So if your tower is in a very busy industrial area, highway, a construction environment, maybe a very urban environment where there's a lot of material, a lot of different environmental debris, or maybe you're in a seasonal effect where you have lots of different pollen and a lot of organics present. It's important to understand what the technology's capabilities are. So now you have pollen, you have plant spores, really, even some large atmospheric dust, you have the capability of removing when you're selecting a technology like a screen filter. But when you are in a cooling environment, you're seeing lots of different types of particulates, and we'll go into more detail later. Let's talk about how this technology works. Again, as I mentioned earlier, it's a fully automated operation. No additional external drives or gearboxes are required. It's really a minimal maintenance requirements through its patented bidirectional screw design. So how this works, so water flows from the inlet on the bottom right flange, comes into a pre-screen, really kind of protecting the internal mechanism. Basically, so to eliminate any types of large debris left over from any type of construction, right? Wrenches, rags, Snicker bar wrappers, as Gary mentioned, right? Really to protect the internal mechanism of the filter. As the flow enters into the main chamber or the center of the filter, that's where you find the fine screen. And the fine screen, Evoqua's fine screen, is a something called a sintered 3-layer weave wire mesh screen. And this is a screen that's really high level capability of removing particulates at varying degrees. Water's passed through that fine screen. Solids are collected on the inside of that screen, flow out inside to out, and then out to the outlet on the bottom here. So that's filtration. Quite simple. What really is the magic about this filter is how it cleans itself. Again, no moving part, no external electric motors, pistons, technology, right? No limit switches to make sure you're cleaning effectively or it's operating performantly. We're using inlet water pressure to ultimately act as the force to clean itself. So over time, solids are collected on that internal inlet, that fine screen. Over time, pressure will build at a DP of approximately 7 psi. It will trigger a controlled flush valve. That automated flush valve will open, and now you have two different zones of pressure. You have a high pressure zone on the inlet, and then you have a low pressure zone on the outlet. That outlet is ultimately open to atmosphere or a lower pressure environment. That delta pressure ultimately creates a flow from these inlet nozzles or these suction nozzles throughout the main chamber. Water flows up through these inlet nozzles, down a central hollow shaft, and out two nozzles of the water motor. And those nozzles are oppositely directed. And as water flows out, you actually creates a rotation effect. But then that water is sent outward to drain. So you're starting to flow out the flush line. But you have a rotation effect here. That rotation creates a rotational effect down the shaft, basically rotating the nozzles 360 degrees throughout the screen. But this shaft is actually connected to something called a bidirectional screw at the other end. That bidirectional screw, think of your fishing reel. As you're constantly rotating in one direction, you actually have the reel going back and forth. The same idea is occurring here. We're rotating always in one direction, and at the end of the linear motion, you go in the opposite direction. That allows this nozzle or all of these nozzles to effectively clean 100% of that surface area of that screen very efficiently, very controlled. So ultimately you are getting very high efficiency of removal of that solids collected. So a very functional, a very high efficiency capability of removing your solids. Again, patented technology that allows you to be the ultimate solution of removing particulate in this type of technology. And here, what I just said, video can probably tell you a lot more of how this is functioning. Again, this is just the cleaning cycle. So when you're filtering, none of this is moving. But when you are in a active cleaning mode, this is what's happening, right? Suction valve or flush valve is opened. You have flow from the high pressure zone to low pressure zone, removing that dirt and debris. but you basically have a rotational effect, moving this central shaft down and back, really driven by the bidirectional screw on the other end. Again, no need for any additional penetrations for limit switches or any types of gearboxes, right? This is fully enclosed, only with one capable flange on one side for operations and maintenance. The screens itself need to be changed out on an annual basis, or depending upon the loading and operation of your tower. So why does this matter? Why am I speaking so much about the internal mechanism of cleaning so much? Well, the operation of you want to be choosing a technology that ultimately provides you with the best uptime for your tower. You don't want your filtration technologies going down and ultimately impacting your operation. You want to select a technology that will provide you the best level of water quality, but also at the highest level of uptime. So when you look at the VAF, it's important to understand its internal capability when you're comparing it against other types of screen products on the market. VAF provides really the lowest cost of operation out today. No hydraulic pistons to maintain, no electric motors or gearboxes to maintain and or potentially change out for failure, no limit switches to constantly manipulate and maintain. And because you don't need those technologies, there are fewer levels of penetrations, ultimately providing fewer leak points. That ultimately could be a safety hazard for some of your operations staff. And with our bidirectional screw and water motor, our patented technology, we are very capable of very effectively controlling the cleaning cycle. So you are removing those particulates at the highest level of degree every time. 10 to 15 seconds, and ultimately a cycle is completed, dropping that DP down again for filtrate, for again a full clean screen. And just one more note: when a cleaning cycle is active, the filtration is still functioning. You are not shutting this filter down when you are in cleaning mode. Something very important to be evaluating when you're choosing the right technology. And again, this lastly provides, this type of technology provides the lowest cost or the lowest flush waste in the industry, about less than 1% of the overall feed flow. So taking that all into account, when you look how many parts and components that ultimately could fail and deteriorate, VAF has about 90 plus parts that need to be maintained overall. When you look at piston and electric motors, you're looking at 170, almost 270 plus parts. So make sure you understand and choose a technology that you feel comfortable with maintaining. Okay, lastly, we're going to talk about the filtration, the media filter called the Vortisand Filtration System. And this technology is really built for the utmost asset protection, really for customers looking for the most mission critical asset protection. Because for those of you who are really looking, constantly on a daily basis, monitoring approach temperatures, you're looking at the kilowatt hour or amperage draw on your motors in your cooling towers, or your chiller runtime, right? This is the technology that ultimately will provide you with the highest level of protection. The Vortisand is a high efficiency media filter that really focuses on the lowest end of the spectrum of particulate filtration, really. We talked about centrifugal separators, 100 micron nominal. Screen filters, around 10 microns. And now you're getting into the point where you're able to compete with bag and cartridge filters, but now you're able to do that at an automated capability. You're able to get down to sub-micron performance, less than 1, down to half a micron, in an environment where you're automatically self-cleaning that product. You're not requiring any type of bag or cartridge solid waste. You're completely utilizing a flushable media technology. And this time you're able to go down to bacteria, atmospheric dust, really those really fine particles that are in a cooling environment. Now, why do I continuing to talk about particle size in this presentation? We're continuing showing you various different particle size graphs. We're talking about particle size capabilities and performance. Why am I talking about particle size? Well, when you look at fouling is ultimately dependent upon particle size, and the rate of that fouling is greatly dependent upon the particles that are present in a cooling system, right? And earlier in the presentation, it looks like a lot of you are using a combination of chemicals and filtration. Great, chemicals can only do so much, right? But if you look at a heat transfer surface or various different surfaces in a cooling system, a lot of those surfaces are metallic in nature, right? On a microscopic level, or I should say, those metal surfaces are very rough on a microscopic level. And when you have large particles floating in suspension, those ultimately will not initially detach. Like they'll continue to float in suspension and potentially drop out in tower or in the basin. But those very fine particles, the 1 to 5, are really the first to cling to surfaces and really start to aid in the fouling process. Now, those fine particles start to create a fouling layer. And when you look at what's in a cooling environment, and on the right-hand side of the screen here is a water sample that we ran through something called a particle size analysis. It's a test that you actually can take and allow us to understand more of the resolution of your water, right? I think you probably understand turbidity, you understand total suspended solids, but particle size analysis is a next level water quality analysis that really allows us to understand what your water quality is like and what type of technology you should be selecting. So this is the output of a water quality analysis from a particle size analysis. And what it shows you is the water quality can be broken down into various different buckets. Less than 1 to 5 micron, 5 to 15 micron, all the way up to 100 micron. And when we've taken various different samples throughout many of our sites and our customers, we see that the majority of particles by count, over 95% of the particles are actually less than around 15 microns. So again, very important to understand what's in your water so you can select the right technology. So when we talk about cooling water being so fine particles, such fine size particles, what does that do, right? This is really where you have the first layer of biofilm or biological growth that starts to accumulate and deposit on your heat transfer surfaces. That biological growth starts to potentially create a layer for undeposited corrosion and creates a host of difficulties for your chemical program. So if you can eliminate those fine particles from your cooling water, you're setting yourself up for a lot better success for controlling solids, but also for the overall health of your water treatment program. Now let's talk about the Vortisand technology in a little bit more depth. Vortisand is very different than a multimedia technology. Vortisand uses a silica-based media, but it's a very fine media that we call microsand. It's about 0.15 millimeters in diameter. So we're talking about very, very fine sand comparatively to maybe 2 or 3 times that of a multimedia. So very fine sand. And with this such fine sand, we are able to achieve very high quality effluent that ultimately will have great impact on reducing customer asset fouling, right, what I talked about earlier. And with that, what does that mean? If you can eliminate some of that biofouling layer, you can ultimately achieve up to about 10% savings in energy costs. A very significant impact when you're trying to achieve various different sustainability goals for your site. Now, when you combine the microsand, below the microsand here on the left is basically lower media layers, really just acting as support structure. But the microsand is about 8 inches of very shallow media. So water is ultimately injected into the top of the manifold, and it basically flows vertically down into an injector. We utilize a very unique, it's actually a patented technology, cross-flow technology, with an injector called the Vortisand injector, which basically takes that vertical flow, induces a cross-flow pattern that creates now a tangential flow across the surface of the media, really that scours that top of the layer and really preventing any surface blinding. Now that's very important because if you utilize such a very fine media, you wouldn't be able to achieve such high velocities. But combining the microsand with an injection system such as the Vortisand's cross-flow technology, now you're able to achieve very high performance at the same time of of high velocities. So very important when you have a very tight utility room. Now you're able to achieve the same level of flow, but in a very small footprint. So what we see here is about a 50% smaller footprint of the technology when you compare it to other media types of technologies. And when you look at the shallow bed, so we're using about 8 inches of media here. That actually reduces the overall backwash consumption, right? Shallower bed, smaller flow rate to fluidize and remove that solids particulate collected. So you're potentially able to save about 50% reduction in water consumption. But Vortisand is really combining the media, microsand, achieving submicron performance, with the crossflow injection allows you to do submicron performance at high velocity, something really unique within the industry, ultimately impacting various different cooling systems at a high level. Let's take a little bit closer look into the overall product. Really, this product, the Vortisand C series system, was really was recently released as an improvement directed specifically to customers in a cooling environment, both open and closed loop systems. It's again this technology, fully automatic, capable, plug and play, fully controllable with a PLC. We've really focused on safety, from pressure relief valves to utilizing ASME code vessels to even separating high and low voltage panels, so ultimately reducing safety concerns from when your staff is out on site. We've also optimized the layout. The connections are very easy. And then lastly, we've shrunk down a lot of the overall skid, so you ultimately can leverage a very limited amount of utility room. All right, now we're going to talk about a few case studies here. So here is a Vortisand system that was installed at a Ivy League research university in Massachusetts. And this customer was at a protection for both their open loop as well as closed loop. So this customer actually chose a VC350, which is one of our horizontal units for both the open loop as well as the same flow rate for their closed loop, ultimately providing the ultimate and asset protection for that customer. And then lastly, we'll talk about the last case study, and this is a global hyperscale data center. And this customer was actually really unique, right? They ultimately wanted to protect their mission critical assets from suspended solids, but they also had the interest and need for operating their cooling system with no continuous chemical dosing. For some of you who are interested in a non-chemical approach, Evoqua has some of those solutions. So we actually paired Vortisand with the Evoqua UV system to really deliver a very highly effective chemical treatment program for them. So with Vortisand, we're able to reduce their suspended solids down, below 1 micron, allowing them to achieve about 10% savings in energy. And then they were able to see significant savings in chemicals through the utilization of the Evoqua UV system. And then Vortisand able to deliver 40% reduction in water consumption because of our shallow bed, and then overall reduction in cooling tower maintenance costs, about 50%. Now, I talked a lot about various different technologies, right? Hydrocyclone separators, VAF automatic screen filters, to even the Vortisand high efficiency submicron media filter. Again, all has various different operations parameters and performance capabilities. But it's, again, important to understand the product, but mostly it's really important to start with understanding your own cooling tower. So as Gary mentioned earlier, there's many different locations where filtration could be part of your solution, but you need to know more about your tower. Work with your chemical provider, work with someone who can test your cooling water, and understand where your solids loading are arising from. Is it makeup water? Are you focusing really on basin? Is your closed loop having high iron excursions because of dead legs? Understand your cooling tower, understand where your solids loading is, and understand the particulate size that is in your cooling system. With that in hand, you can ultimately then work with Evoqua staff to select your best solution, depending upon the operations requirements, but ultimately what your goal is at your site. Now, Evoqua has the capability of performing extensive lab services. So we have many different laboratories that have the capability of doing suspended solids, turbidity testing, but also, as I mentioned earlier, particle size analysis. Guys, understand what's in your water and what types of particles you're dealing with. Evoqua has the capability of providing various different commissioning, troubleshooting services, so we can come on site and work with you to understand further. And then lastly, if you have a very problematic site where you need a little bit of extra help, or you want to have a short-term rental, we have those capabilities in our fleet of various different capabilities. So please work with us and let us help you, let our knowledge and our experience help you further. At this time, I would like to thank you for attending today's webinar. We're going to go into our Q&A session hosted by Sonia Muniz. Sonia.
Good morning, everybody. My name is Sonia Muniz. I am the sales manager for the Vortisand and VAF product lines here at Evoqua. We want to encourage you all to ask any questions you have for the team today through the Q&A box that you have on the tool. We'll get started with the very first question. I'm going to be sending that one to Gary. Gary, what are the materials of constructions for the VAF filter?
All right, Sonia, thank you. So comes standard with stainless steel. So that's what you typically have on all the VAF filters, stainless steel vessel. We do have a smaller version, which is plastic, just more economical, more likely to get projects approved, that sort of thing. But by and large, the materials are going to be the stainless steel vessel. And then you saw some of the internals. There are some plastic pieces and such, but O-rings, seals, that kind of thing. But by and large, it's stainless steel, made in the USA, baby. You don't say that very often anymore.
316 stainless steel.
Yep. 36. Yeah, thank you. 316.
Thank you. Mike, on the Vortisand side, we have a question. What size pipe will the Vortisand system handle?
Yeah, great question. Thanks, Sonia. So Vortisand, we have various different models available. So we have the capability of handling flows from I would say around 20 GPM all the way up to over 1,000 GPM. So that comes in various different sizes. So if you have a certain specific flow rate, we have a capability of handling that flow. But again, a minimum flow rate about 20 GPM.
Okay, good. Gary, is there any power needed or required to operate the VAF filter?
There is, yes. You will need to bring power to it. We do have some different options. There are even, if you're out in the middle of nowhere, there's some battery powered options. But by and large, it's just your standard. What is it? 120 volt power source that you would need to run that. Correct. And that's running the flush valve and the controller that kind of help automate the system.
Okay. What type, Mike, of media is utilized in the Vortisand microsand filtration? What type of media?
So we use a different type of media compared to various other. So Vortisand uses a very different media than most traditional multimedia filters. It's a silica-based media, but we are very focused around not just the size, but also the size and shape. Very uniform media. It's a very specific type of media that allows us to get the utmost performance. But the media is an NSF certified media that can be utilized in all different types of applications.
Okay, along those lines, how would you compare the microsand media versus glass media, Mike?
Yep. So we actually use a glass media in some situations. So glass media has a lot higher surface polish, right? So in some situations where there is high iron content, maybe such as your closed loop, for instance, you potentially could get a little bit of better backwash efficacy or removing some of that solids off that glass bead. So that's really the only difference per se. There's some different sizes of glass beads, but overall glass beads versus our traditional silica-based media, it's really depending upon the iron content levels.
Okay. Gary, on the BAF system filters, when the system flushes, does it flush both the water and the particulate that was in the screen?
Yes, when it flushes, those nozzles are sucking in mostly the debris that's on the inside of the screen that builds up. And then Mike said it earlier, it's very efficient. It's sucking a little bit of water. It's less than 1% of the system flow. So it's mostly the debris, a little bit of water through the center of that tube, pushes out, right, causes that rotation, and then that goes down the drain. So yes, mostly debris, a little bit of water is what it's vacuuming.
Perfect, thank you. Mike, for the VAF, how is the shaft itself driven without motor power?
Yeah, good question. There's a lot going on in that internal mechanism. As I mentioned earlier, it utilizes internal water pressure. So we actually have a minimum pressure requirement of about 35 psi. So, but that should not really be a problem, say in a recirculation system of a tower. If you're doing a basin system, you'll need ultimately a pump, but that's relatively understood to driving a side stream off of that basin tower recirc. But again, 35 psi minimum. Why? You need that pressure to ultimately create a pressure differential. And that differential ultimately creates flow, suction force, as Gary just indicated. It creates a suction flow through the high pressure zone to the low pressure zone, creates a flow velocity and a suction force. But that flow exits into the flushing chamber in our water motor. And that water motor is really just a nozzle, two nozzles that are pointing opposite direction. And when that happens, you actually have this pinwheel effect. That pinwheel effect then rotates this central shaft then that is connected at the other end to the bidirectional screw. So basically you have constant rotation one direction, but it ultimately goes, the nozzles go back and forth, constant.
Okay.
So that allows you to move that nozzle back and forth over across the entire surface area of the screen in a linear direction without an electric motor. You don't need an electric motor to move that central shaft or nozzles across the screen.
Okay. On the Vortisand side, Gary, with the Vortisand filter, can you run basin cleaning nozzles?
You can, yes, you can do that. It's an option. You don't typically see that, but with the Vortisand, you can do that. A lot of times folks might do that, and they might put it into a hydrocyclone first to get those big particles out there, and then let the water stream continue on to the Vortisand. So there's kind of it's not just one of the technologies that we spoke about today. You might use them in tandem. So you may have that basin sweeper pushing all those big particles up, let the hydrocyclone take them out, let the Vortisand then kind of fall it up and, I don't know, polish the water or whatever you want to call it, but get that water really clean down to a 0.5 micron.
Okay. What are the materials of constructions for the centrifugal separators product line, Mike?
Yep. So we've really focused on a carbon steel construction. So heavy duty gauge carbon steel, really providing about 150 psi design pressure. Mm-hmm.
Gary,
stainless steel options are available as well.
Okay. For the BAF product line, what is the minimum pressure required to operate the system?
Yeah, so there's a bunch of different sizes on there, but Mike mentioned earlier, on the smaller ones, I think you need about 35 psi, and then on the larger ones, it just goes up there a little bit. So it just depends on the model, but yeah, most of your water systems are going to be 100. The vessels are rated for 150 psi normally. Now you can make higher pressure vessels, but typically in those water systems, you'll be at that 35 or higher. And then again, on the bigger systems, you're going to probably have more pressure anyway. So it just kind of depends on the model, but at a bare minimum, 35 psi.
Okay. For the Vortisand filters, Mike, how frequently do we need to backwash the Vortisand filter itself?
Yep, that's a great question. It's going to depend, right? And that's always a stock answer that no one wants to hear. But when you install a Vortisand on a dirty tower, you're going to be backwashing quite often, right? Why? You might think of that as a negative. Well, the filter is actually doing its job, right? You have quite a bit of loading. You might have 20 ppm of TSS. You might even have higher initially, but over time you're basically collecting all that solids, and you're collecting a lot more solids than you would be by using maybe a traditional multimedia. You're going to be collecting more solids than a screen. You're going to be collecting a lot more solids than a hydrocyclone separator. So Vortisand, you have such a high level of capability of removal that you're going to be capturing solids. You're going to be hitting a DP about 17, and then you're going into a flush mode. So that ultimately will require initially quite a bit of backwash rates. Now we backwash on average about 8 minutes. So it's a lot, I would say. At the same time, you're backwashing at a lot lower velocity. So it's a different type of overall backwash sequence. We've seen once towers are cleaned up, we've seen customers maybe backwash once or twice a day, or even less. So it greatly depends upon where you are in the phase of cleaning your tower. Initially, it's going to be quite often, could be multi times a day, but ultimately it could drop significantly down to a very stable state.
Along the lines of flushing, so I'm going to keep it with you, Mike, but for the BAF product line, how long do you flush, and do you operate while you're flushing with the BAF filters?
Yeah, good question. So yes, you are filtering, I should say, while you are in a cleaning cycle. So you're always filtering. As you're filtering, solids are collected on the internal screen. As you hit a DP of 7, you'll initiate a flush cycle, and that flush cycle can range from 10 to 15 seconds for ultimately removing that solids, and then you'll basically clean the screen for ultimately a fresh runtime again, effectively reducing your DP back to around almost 1. So a very short duration of cleaning capability that you're continuing filtering while you are cleaning.
Okay. Thank you, Gary. In regards to maintenance, what is required for maintenance for both product lines? We've had it asked, but for BAF and Vortisand.
Sure. Just a quick clarification on what I said earlier. The minimum pressure you need is 35 PSI for all of them. There's different flow rates to get that minimum pressure. That's what's different for the different models. For the maintenance of each, let's start with the VAF. The VAF has a few wear parts. The bidirectional screw, as that shaft travels back and forth, you can imagine that's one item that needs to be maintained once a year. And then there's some O-rings that are as part of the unit, as well as some seals. And the cool thing about the VAF is you can unbolt the back, pull the entire internals out, and replace those parts very, very quickly. And so we know those are wear parts. We actually provide a little preventative maintenance kit that you can have on hand and just pull it out, replace them, and pop it back in. So once a year or so, I'd say at least once a year for the VAF, you want to replace those wear parts. When it comes to the Vortisand, the maintenance on that is pretty simple. Roughly every 5 years, you're going to replace that media. So of course, if you have a really heavily fouled system or a much cleaner system, that would add more or less to that time. But generally speaking, we recommend replacing that media layer every 5 years. So that's it for both of those products, really low maintenance.
Okay. Mike, is there a way to monitor how blocked the BAF screens are in the system?
Yep. So we have a DP gauge on the filter that's provided standard on all products that absolutely could be used for troubleshooting as well as monitoring the solids that are ultimately collected.
Okay, we're coming to the top of the hour here. We have, I think, time for one more question. We have more additional questions coming in. We'll make sure that after the conclusion of the webinar, we follow up with you and answer any additional questions you might have. So the last one, I'm going to send it to you, Gary. Does the Vortisand backwash frequency decreases as the water is clean?
Yes. And the sake of time, yes. It's the less differential pressure that's going to build up with the cleaner water, you're going to backwash less frequently over time. Correct.
Okay, perfect. So we're coming to the top of the hour here. We all want to thank you all for joining us today to learn about our technologies. We're looking forward to speaking with each of you and answering any questions you might have about our technologies, and as well as about the needs you have in your facilities for our technologies. Again, thank you all, and we wish you all a very good day, and we'll be reaching out to the team soon. There will be a recording of the session that's going to be available on facilities.net and as well as our website. Thank you all for joining us and have a great day.
Thank you, everybody.
Thank you.